This is the video on exponent rules, adding, subtracting, dividing, multiplying, well, possibly, exponents, and understanding why they are the way they are and how they interact with geometric series and sequences. Right, geometric sequences. So, what are exponent rules? Well, perhaps you've seen these before. They're the sort of things that say if I have 2 to the a, and I multiply it by 2 to the b, then I should get something like 2 to the a plus b. Something like that. Now, why would something like this be true? So why is this true? Or why would something like this be true? Well, let's see. Let's take a look at an example. Say 2 to the 3 times 2 to the 6. Well, 2 to the 3, what is 2 to the 3? Let's think of it first like this. Let's put some parentheses around this. So what's 2 to the 3? Well, that's 8. And what's 2 to the 6? That's 64. Now what is 8 times 64? Well, that of course requires a little bit of arithmetic now, doesn't it? So 8 times 4 is 32. Carry the 3. And 8 times 6 is 48, 49, 50, 51. 512. Okay. Now what about if we use this rule? 2 to the 3 plus 6. That's 2 to the 9. Which if you ask your calculator what is 2 to the 9, that is in fact, hey, 512. Check. They work. Okay, so this idea kind of works. Why does it work? So it certainly does work in this case. Let's sort of take it apart. So 2 to the 3 times 2 to the 6. What does that mean? Well, 2 to the 3 is really 2 times 2 times 2. Now what about 2 to the 6? Well, that's 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Yep, got them all. So 2 to the 3 times 2 to the 6. Oh, okay. Well, if you look at that, you know, I can change the parentheses now, couldn't I? I can go 2 times 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 2. Now you know why exponents were invented. This is kind of annoying to write out all these 2's, right? Now how many are there? Let's see. There were initially 3 of them here and 6 of them here. How many 2's are there? Well, I didn't lose any 2's now, did I? Well, hopefully I didn't. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them. So that says that this thing is in fact equal to 2 to the 9. Hey, cool. So that's why this kind of rule works. And in fact, it works if I replace the 2's with like any other number I like. It doesn't really matter which number I use here. And of course, this a and b, those are variables already. So let's write the first exponent rule in this way. Something maybe we'll call it b for base to the a, b to the c, is b to the a plus c. Now, that's pretty nice. Now, what about say, if I've got, instead of multiplying, I divide? So what about division? Well, let's do the same kind of idea. So what is 2 to the 4 divided by 2 to the 2? Well, what's 2 to the 4? That's 16. And what's 2 to the 2? That's 4. And 16 divided by 4 is 4. Which, wait. Let's put that as a power of 2. That's 2 squared. That is really the same thing, hopefully, here. Looks like it's 2 to the 4 minus 2, doesn't it? Well, why would I say that? Well, let's sort of unpack this and write it out. 2 times 2 times 2 times 2, that's 2 to the 4th. divided by 2 times 2. Okay? Right, so let me group these and group these. And let's see here. What really is happening here is we're canceling. I'm like canceling this one with this one, and this one with this one. And I'm left with just 2. There. Hence, the right manipulation seems to work. So this, of course, is, in fact, 2 to the 2, as we just advertised. So division, like, cancels things out and subtracts away from these exponents. So we've got a second rule that looks like this. B to the A divided by B to the C. That's B to the A minus C. Okay, well that's pretty cool. But now this can like run us into deep water pretty quick. Here, if A and C are positive numbers, that's like everything is nice here. Here, A and C, they're, well, wait a minute here. What if I get A minus C negative? Then I'm going to have B to the negative. What does it mean to multiply a number by itself negative times? That's like troublesome, isn't it? Well, except for the fact that maybe we do it like this. So what if A is less than C in the division rule? Heck, what if it's even equal to C? Then we'll get B to the 0. Well, so specifically, B to the 0 equals what? Well, let's take a look at what this formula says B to the 0 might be. Zero is a number, right? Thankfully. And it's a number that's like any number minus itself will give you 0. So, like, it's B to the A minus A, where A can be just about anything. In fact, it can be any number. Okay, well then let's sort of pull this apart here. It should be B to the A divided by B to the A by this formula, just read backwards. I'm just replacing the C with another A. Hey, but I know what this number is. Any number divided by itself, like B to the A is in the numerator, B to the A is in the denominator, that's any number divided by itself, that's 1. So in particular, note any number to the 0 power is 1. Yeah, that's pretty cool. Any number to the 0 power is 1. Now, all right, so that handles the equals, but what about the negative? Well, it's the same idea. B to the negative something, say B to the negative 1, well, that would be, really, that's B to the 0 minus 1, isn't it now? Like, any negative number is just 0 minus that positive number. So this is same formula, B to the 0 divided by B to the 1. Now, we know what B to the 0 is. We just figured it out. It's 1. And what B to the 1? Well, that's just B. So B to the negative 1 is just 1 divided by B. Ah, well, that's kind of nice. So, like, if I had B to the negative 2, put a 2 there, well, then this would be a 2 here, and a 2 here, and B squared. So B to the negative 2 really means 1 over B squared. So in particular, B to the negative anything is really just 1 over B to the that. So in fact, I don't have to put this 2 there. I can put an A there, A there, an A there, and an A there. But that's what this formula just says on its own, really. It says that if I put in a 0 and then my C, then all right, and that tells me what negative exponents mean. It tells me what 0 exponents mean. Now there's something a little more funny going on. Like, I'm taking exponents here, right? And what if I take exponents of exponents? Sounds like that would like make the problem worse. But it's really not so bad. So like, if I have 2 to the 3, that's some number, and I raise it to the 2 power, what does that mean? Well, we just sort of unpack it. What's 2 to the 3? That's 2 times 2 times 2. Of course, that's 8 squared. So I got how many of them right now? I've got 3 of them. And I'm going to square it. Well, that just means, like, take this and multiply it by itself. Now, how many do I have? Well, if I sort of regroup, switch those parentheses around, I now have, well, hey, I've got 6 of them. Now, what's 6? 6 is 3 times 2 of them. Which this really suggests that the exponent rule, b to the a all to the c, that's really b to the a times c. Okay. That's pretty good. Now, wait a moment here. This suggests that there's something else we could say. I mean, we've been dealing with whole numbers up here. These a's and b's and c's as exponents are all whole numbers, and because I'm counting how many numbers I've got, how many factors I've got. And when I made them negative, that essentially put factors in the denominator rather than in the numerator. Now this is a little more sophisticated, because now when you multiply numbers, okay, if you multiply whole numbers, you still got whole numbers. What if I start putting in fractions here? Now I know everyone doesn't like fractions, but fractions are pretty handy here. Check this out. What's b to the 0? Or rather, what's b to the 1? B to the 1. Well, that's just b. But when we looked at these negative exponents, and these, what do we do? We looked at putting in the 0, this is now a 1, and writing it a different way. What's 1 written in a different way? Well, I can take any number and divide it by itself, right? Okay. So like this could be b to the a divided by a. That's that a divided by a is 1 for any number a. Okay. Now what is, of course, a divided by a? That's a fraction, but I could think of it as a times 1 over a, couldn't I? Yeah, I guess so. And then if I'm using this rule, take this rule very seriously. I mean, the rule says I should put some parentheses around there. Take that rule very seriously. Read this backwards. What happens? Then it suggests that this is true. Taking b to the a and raising it to the 1 over a, that should give me back b. Well, that's kind of funny. Kind of funny. So this fractions being a little bit strange. But let's look at it with a specific number. For instance, let's look at it. Well, I like 2's. Let me switch to 3's just for fun here. This equation here says that 3 is equal to, and let's write here, 3 to the a, 1 over a. Now, let's put a in there as something special. Let's put it in as some number we know. Well, what's this do? Well, this is 3 squared. What's 3 squared? That's 9. So 9 to the 1/2 power is 3. Now, what is that saying? That's saying, then 9 to the 1/2 power gives me 3. What about, let's try with 4. Let's see if there's some insight there. That's 16 to the 1/2 power is 4. Hey, I think I see a pattern. This to the 1/2 power is undoing the squaring. It is a square root. In fact, here's the important principle here. B to the 1 over n is the nth root. B. So this lets me write down any power roots that I want, like square roots, cube roots, fourth roots, fifth roots, whatever roots that I like. Now, of course, you can run into problems with negative numbers if you're doing square roots. Certainly can run into problems if you're taking any even power root of a negative number. If you're not careful, you'll end up in complex numbers, which, at least for this course, we're not dealing with. But this is the basic exponent rules. So let me summarize. A bunch of exponent rules. that are worth knowing and writing down, at least until you get them good. The first one is b to the a times b to the c. It's b to the a plus c. B to the a divided by b to the c is b to the a minus c. And b to the a to the c is b to the a c. And from these, b to the 0 is 1. Any b at all to the 0 is 1. And the other thing is b to the 1 over n is the nth root of b. So these are the exponent rules that you'll want to run across and know and have down pretty well. It'll help you a lot in manipulating expressions of various sorts that involve exponents.